Experiment 12, preparation of alum. Alum is a water clarifier, and the actual chemical name for alum is potassium aluminum sulfate dodecahydrate. That's KAl, 2 sulfates, and then 12 waters in the formula. It's a two-step synthesis with a third step being that you cool the sample. First step, you have aluminum and potassium hydroxide mixed to form a hydroxide complex. Then we take that hydroxyl complex and react that with sulfuric acid to form potassium aluminum sulfate. Once we have the potassium aluminum sulfate, we cool that, and then eventually it forms the potassium aluminum sulfate dodecahydrate, which is your alum, which is the product that we're looking for in this experiment. The major calculation in this experiment is the percent yield, okay, which is your actual yield, which you got in your experiment. So you're measuring that on the balance after you finish the experiment, divided by theoretically what I should have attained. So you have to calculate that to figure out what that should be, time 100%. And that's time 100, that percent is just a unit. So how do we calculate the theoretical yield? Well, you start off with your grams of aluminum, whatever that mass is. And then we're going to have to do a mole-to-mole ratio, so we're going to have to get that into moles by doing our molar mass of aluminum. So you got 26.98 grams of aluminum for every 1 mole. So then my grams cancel. Then I have a mole-to-mole ratio between the potassium aluminum sulfate dodecahydrate and aluminum, which is a 1-to-1 for every one of my compound. There's 1 mole of aluminum. So then that cancels out my moles. And then I got to get that moles into a mass. So molar mass again. So for 1 mole of my potassium aluminum sulfate dodecahydrate to have 474.44 grams, which is the molar mass, which is including that 12 waters. Okay, that is the whole substance molar mass. So my moles cancel, and multiply that out, and I'll get my mass. That's my theoretical. That's what's going to be in the denominator of that percent yield calculation. And all that's going to be dictated by the mass of your starting point of your grams to how much you should get theoretically in the end. Some cautions in this experiment. First one, you want to heat gently. If you heat too fast, it's going to overflow, which means sample's going to overflow. So you want to start up very slowly. If it starts to bubble, make sure you turn down the heat. Heat until all aluminum dissolves. How do I know all aluminum has dissolved? Basically, you should have little transparent paint flakes floating around with no shiny back on it. Okay, that means all aluminum has dissolved. Your first filtering is with the regular funnel with a small amount of glass wool. All we're trying to do is get that paint flakes separated. Okay, so that's all we're trying to do is get rid of the paint flakes. Filter that into a 250 milliliter beaker. Then you're going to go through a couple of steps, and then you get to the ice bath. Okay, after the ice bath, when we're talking about filtering, we plan on doing that filtering by suction funnel to aspirate that filtrate from the solid. Okay, so we're trying to pull out all the moisture we can out of that. So to do that, I would suggest that step 1, obtain the mass of the funnel in a wet filter paper. Okay, because we're trying to get the mass of that solid after. Clamp the flask to the ring stand, connect the tube to the flask and the aspirator, insert the funnel, and then turn on the water. Then you filter your sample, pour it into that funnel. Wash the sample with portions of 1-to-1 ethanol water. Do not use pure deionized water. That will make the product soluble and it will break up. So you want to use the ethanol water combination. Disconnect the tube to the aspirator and turn off the water. And this is important. When you turn off an aspirator system, you're going to take the tube away from the aspirator, then turn off the water. Otherwise, you get a back filtration, which will affect you if you cared about the filtrate. Then obtain the mass of the funnel, the wet filter paper, and the wet solid. The difference between your mass in A and your mass in F will give me the mass of my wet solid. Now, that's the number that we're going to use as our final product mass. Now, do I have an error in this process? When I go to do my percent yield, the answer is yes, because I have a wet solid. That wet solid, that wetness has mass to it. It's water mass. So I don't have the actual mass of just my solid. So I'm going to get poor results from that calculation. That's something you need to note in your lab report, because there's a possibility you may get greater than 100% product because you have water there. Okay, and that's why that's happening. We don't have time to dry the sample and get actual mass, so we're just going to use whatever you get. Okay, so just make sure you note that as a source of error in your experiment. Okay, this sample is still wet, so the actual final mass is not the mass of just your complex. Okay, it's also the mass of water involved there as well. And then the other important note I'd like to make is that we're going to do this in groups of 4. Okay, you can do it as a table of 4 people at one table working on this experiment.